Okay, so continuing on here with composition of functions in 3.6 in Trig, we were doing tables and following these tables when we last left off. So now here's two different tables, so let's see what we learned from the last time to try to follow these and plug them in. So this is saying do f of 2. What that means is plug in f of 2. So, there's a 2. When I plug that in, I get 4. So now what it's really saying is plug a 4 into f again. So I'm going to plug a 4 into f and I get 1 as my answer. G of 2. So G of 2 means, okay, I plug in 2 for G and I end up getting 1 as my answer. So now it's saying, okay, go back into G but plug a 1 in. When I plug a 1 in, I end up getting 4 as my answer.
Showing off. Figured out how to work the Google on the intranet machine.
So, a meteorologist is inflating a spherical ball with helium gas if the radius of the balloon is changing at a rate of 1.5 centimeters per second. Express the volume of the balloon as a function of time. So, there's the formula for volume of a sphere, and it's saying that it's a rate. Alright, so it's 1.5 meters per second. So that's why I have it in terms of 1.5 t, because we don't know what t is. So we want to express the volume of the function of t. So that's why the distance that it's actually going is going to be 1.5 t, because remember, distance equals rate times time. The rate is 1.5, so distance equals 1.5 t. So that's why I'm kind of substituting in a 1.5 t for my answer. So I take the cubed through, and when I do that, I end up with, I just rewrote 1.5 as 3 over 2. That's all. They're the same thing, so don't freak out there. I end up getting a 27 cubed, right? 3 cubed is 27, 2 cubed is 8. So I end up getting 4/3 pi 27/8 t cubed. So I'm just going to combine some like terms here. That's all that I'm doing there. So I end up getting 108 over 24 pi t cubed. And it says express the volume of a balloon as a function of t. So now this is basically saying, hey, get a t by itself. But before I do that, I realize I can divide a 12 out of these. So I end up with 9 over 2 pi t cubed. So express y as a composition. So this is kind of working backwards. This is me saying, hey, my final answer is this. How did you get there? What did I start off with? Alright, well, here's a hint. The hint is when you see parentheses, because this is hard for some people to grasp. Okay, so when you see parentheses, normally look what's inside the parentheses. Whatever's inside the parentheses is normally your f of x. And whatever the outside is your, whatever's inside the parentheses is your g of x, because that's what you plug in first, and what's on the outside is your f of x. So what you plugged in is g of x. This is what you plugged in, right? Because g of x is on the inside, so I plugged in 2x plus 5. So that would tell me that g of x is probably 2x plus 5. And then what would I plug that into to get this answer? X to the 8th is what I'd plug that into. So if you took this 2x plus 5 and plugged it in, you'd end up getting the answer. This is a lot of trial and error. There's no real one way to do composition of functions backwards, but what I can tell you is whatever you think your answers are, you can always check them to see if you get what you started with. And if you get what you started with, then you did it right. So the point is, I would take this and plug it in. Do I get this as my answer? Yeah. If I take 2x plus 5 and plug it in for x here, I get 2x plus 5 to the 8th power, so I knew that I did it right.
Good evening. I'm Ron Burgundy, and this is what's happening in your world.
2x minus 16 and root x. So we said before that find out what g of 3 of x is. So that means plug in a 3 here. So I get the cube root of 3. And then plug in the cube root of 3, the square root of 3 in. So you end up getting negative 13 as your answer. So what it's saying is when you plug in a 3, you end up getting negative 13. However, let's graph this. So in order to graph this, square root of x squared minus 16 is basically saying, hey, graph x minus 16. Right? When you simplify it, you get x minus 16. But the problem is, that's why we had those stipulations. You find the domain of each of these and see where they overlap. They overlap. We said this is negative infinity to infinity, and we said that this is 0 to infinity. So we said the domain of this was from 0 to infinity, which means I only want to graph this line from 0 to infinity. So I only want to graph this line from 0 to infinity. Well, the y-intercept is negative 16, so that's why I start here at 0 and went down, negative 16, up 1 over 1, up 1 over 1, and so on to get my points for my line. Once again, this is why the domain is important, because the graph is only graphed from 0, which is why I graphed here, to infinity. That's why the graph only starts here and goes. I don't have it going in either direction to infinity. So when you're supposed to graph composition of functions, you only graph composition of functions where it says the domain is supposed to be from.
Did you ride the bus to school?
So f of x equals x cubed minus 4x squared. Sketch the graph of this. So what it's saying is, okay, plug in a negative 1/3 x and then multiply it by a half. So everywhere there's an x, I'm plugging in a 1/3 x. So 1/3 x cubed, 1/3 x squared. So I have to take that 3 through to both items. And when I do that, that gives me 1 over 27. And when I take that squared through, I end up getting an x squared now. Just like I got an x cubed here, but now that's 1 over 9. And when I push it together, that is 4/9. However, I still have to multiply that by a negative 1/2. So I multiply that whole thing by a negative 1/2, which now gives me a negative 1 over 54x cubed plus 4 over 18, because negative times a negative is a positive. 1 times 4 is 4. 2 times 9 is 18x squared. Once again, if you just use your graphing calculator, you can get a table by pressing second graph. You'll get a table, and you can take that, plug it in, and see what the graph looks like. That's what my recommendation would be to solve that problem. And you saw there quickly before I went, just a little curved. It's a cube, so it's going to cross at 3 spots.
You cannot hurt a Twinkie.
Just remember when graphing composition of functions, though, that you want to graph them only where the domain is. That's the big key with that last section with graphing. Only graph composition of functions where the domain is. If you have any other questions or concerns, please let me know, and there's some homework problems you can do in the book.